For question number 6, again, let's go back to the beginning. So we need to, well, let's see what we need to do. We need to define a function. The vertical distance above the ground, again, reference to the ground. So vertical distance, that's going to be a sine function as a function of the measure of the angle in radians. Okay, so we're looking for some function in terms of the radian measure of the angle. So we'll just use theta. That's typically what we use. We know it's going to involve sine. But remember, sine gives from the center of the circle. So let's go back to the very setup that we did up here. Nope, that's the race car one, not that far for this question. The center, remember, is, so the wheel itself was 5 feet off the ground, but the center is an additional 35 feet, so it's a total of 40 feet. That's what we're going to need to use. Okay, so we come back down to here. So we want the sine of theta, and then we multiply by 35. That gives us the distance above the center above the center of the Ferris wheel. But where is the center? The center is 40 feet off the ground, so we have to add 40 feet to that. Now sometimes this will be a negative number, right? So we subtract it from that, but it'll never be less than 5, right? By the time we're done. I mean, otherwise you're going to hit the ground, right? So you'll always be at least 5 feet above the ground, and this will make it happen. So you can take a look at that. And really the only thing you need to define here is that theta is the angle in radians. So I guess we could just say theta okay, that was number 6, just like that. Had they wanted the distance to the right, then this would have been a cosine. Okay. Had they wanted the not measured in feet but measured in radii, then we wouldn't have this 35 here. We would just do sine of theta. That's going to give us in terms of radii. But since they want actual feet, we have to multiply by 35 here. And then remember, we have to, it's this all in reference to the center of the circle. So we have to say, where's the center of the circle? It's 40 feet above the ground.